So what we're going to do today is really just talk about your characteristic charts and filling those in. So here you're not going to graph a single thing. I'm going to give you the graph on all of them, and we're just going to talk about how we fill in that characteristic chart for each of them and make sure that we've hit some of those important talking points there. So here I've just given you a variety of graphs, and again your job is just to figure out this chart. What I'll also talk about here is identifying and classifying the types, because that's what we did last time and it's a good practice as well. So this one would be an absolute value function because it is a V shape. So for example, I know my equation would look like this. Here I'm not necessarily asking you to write the equation and fill in this information in, but it is good to be thinking it through. So like for example, my vertex is at 1, 3, so my graph went right 1 and up 3, so my H would be 1, my K would be 3. The A value, I know it's negative because it's upside down. It also looks steeper than normal, and if you look at the slope, it goes down 2 over 1, so this A would actually be a negative 2. Now again, that's not what I'm asking you to do here, but it is always good to practice and think through. What I am asking you to do is to fill in this whole chart. So for our absolute values, you can plug in any x value you want. The other thing we know is it will go forever to the left and forever to the right, which is what domain is. So it would be negative infinity to infinity. Range is your bottom to the top. The lowest this graph will go, it's going down forever in both directions. So the lowest it will go is negative infinity. The highest it will go would be 3. And I do get 3 out as an answer, so I need a bracket there. You will notice with this that you have the entire chart, so you do have to be able to identify if characteristics exist. So here, asymptotes do not exist on an absolute value function, so I'm going to put none. You do have to write that. Holes, I don't have any. But we do have limits for everything. For your limits on the left and right, you're going to fill in the far left of your domain and the far right down below. And then you're thinking about where your graph is going in each of those directions. To the left, it is going down, which means it's going to negative infinity. To the right, it's also going down, which means it's going to negative infinity. For relative extrema, you're looking for a max or a min. It doesn't necessarily have to be the absolute max or absolute min, but in this case it is. I have a maximum for this function, and that maximum is at 1, 3. So your relative extrema is always an ordered pair in x, y. I don't have a minimum because it's going to keep going to negative infinity, so that would be none. For increasing and decreasing, on the left-hand side of my graphs over here, it is going up, it is increasing. On the right-hand side, it is going down, it is decreasing. It changes what it's doing at 1. Again, you always tell me your x value. So to the left of 1, it is increasing. To the right of 1, it is decreasing. So my increasing value is from negative infinity all the way to 1. And that needs to be a parenthesis because at 1, it is turning around. And it is increasing from 1 all the way to infinity. Here, I'm going to give you your x and y values so that you can just tell them to me for your intercepts. So my x-intercepts are where it crosses the x-axis. So at these two ordered pairs, negative 0.5, 0, and 2.5, 0. And then the y-intercept is right here at 0, 1. And so that would be your full chart for this absolute value function. This next one, from looking at it first off, I know it is a radical function, just based on the shape and talking about our characteristics from last time. This one is specifically a square root. And so hypothetically, the equation would be in this form. The h and k, again, move you left and right and up and down. Your a stretches or shrinks or flips it. So again, for example, with this one, I know my h would be negative 2, so this would be x plus 2. My k would be at 3, so this would be 3. My a value I know would be negative, and then we'd have to figure out any stretch or shrink. But let's mostly just talk about this characteristic chart. For the domain, again, that's the left to right of your function. The farthest left this function goes is right here at -2. It does have a point at -2, so it needs to be a bracket. And then it goes to the right forever, so to infinity. For my domain, it's bottom to top. The lowest it goes, it's going to keep going down over here. So the lowest it goes is -infinity. The highest it goes is right here at 3. These again do not have any vertical asymptotes or horizontal asymptotes or holes. Those showed up only in units 4 and 5. For the limits, we fill in our domain, so -2 and infinity. As I get closer to -2, my graph is getting closer to 3. And as I get closer to infinity, going further to the right, my graph is getting closer to -infinity. It's going down. Highest point or at lowest point, I do have a maximum value here. This starting point is the highest point my graph gets to, so -2, 3. I don't have a minimum because it's going to keep going down and down and down forever, and it never turns around. Looking at this, our radical functions only increase or decrease, and this one in particular is constantly going down. So it is only decreasing. Your x-intercept is right here, so it's at 7, 0. And your y-intercept is right here, or at the 0, 1.586. So this function here is one of our polynomial functions. Since it has these curves like we talked about. This one would specifically be a cubic because I have one end going down and one end going up. Meaning, and your odd behavior for end functions, your end behavior for odd functions, I apologize there, is when they're going in opposite directions. We did talk back when we learned this unit about how to write an equation for this, but it's just not what I'm going to prioritize right now, so I will skip talking about the equations. For your domain, you're thinking how far left and how far right. All polynomials have a domain of -infinity to infinity because you can plug in whatever you want. They will go forever to the left, forever to the right. Range is bottom to top. This one is both going down forever and up forever. So it will be -infinity to infinity. I have no asymptotes. I have no holes. Looking at my end behavior, to the left, it is going down. So this is going to be f of x equals -infinity. To the right, it's going up. So also f of x, or this one will be f of x equals +infinity. This is where we will have some more relative extrema values. That's why this word relative is here, because it doesn't have to be the highest or lowest point total, just in that particular region. And here I actually have a max and a min. My maximum is going to be here where it turns around, and so I have a max at 0, 1. My minimum, same thing, but where I turn around and I have a minimum instead, so 1, 0. And again, these are ordered pairs, not interval notation, but it does look similar. With these, our domains, or not our domains, are increasing and decreasing. We're a little more difficult. This one is increasing at first, then it decreases, and then it increases again. So we're going to have a couple different intervals. So what we think of at first, it's starting at -infinity, so all the way over here to the left, it is increasing until this point at the maximum. And you want to look at your x-coordinate, so it is increasing until 0, so -infinity until 0. Then at 0, it starts decreasing all the way until it turns around again, or at 1. Then at 1, it starts increasing again, so I switch back up to my increasing line. And it will now increase forever and ever and ever, so until infinity. For your x-intercepts, you again want to find these, so it is both at -0.50 and 1, 0, and then your y-intercept is at 0, 1. Okay. This one is going to be one of our rational functions. So this is from Unit 4. Our functions looked a couple of different ways as we went over in that original intro video. And so this could look a lot of different ways, but we'll just go through it. When we had our rational functions, the first thing we did was figure out our asymptotes and holes. And so here we are going to have to look at our graph and kind of figure out what we think those are. You will have both a vertical asymptote and a horizontal asymptote if your graph looks like this, where you have your two curves in both directions, and your asymptotes are whatever your line seems to be approaching. So if I draw this in, for example, it seems like my graph, both as I go up and down, is approaching 4 for a vertical asymptote. So I'm going to put x equals 4. And for a horizontal asymptote, it appears to be approaching this 3. I will always pick for you whole numbers, so don't try to give me decimal values for your asymptotes or anything. Ones I will give you here will be whole numbers, so just find the nearest whole number that those lines are approaching, or those curves are approaching. A hole would show up on your graph as an actual open circle drawn in, so this one doesn't have any holes. For our domain, it is everything except for this vertical asymptote, which is at 4. So my domain goes from negative infinity to 4, and then from 4 to infinity. So again, what that's talking about, I can plug in anything I want from negative infinity all the way up to this line, but if I plug in 4, I get an error. So it's everything over here is negative infinity to 4, and then 4 to infinity, because if I plug in anything over here, it will work also. Your range is similar, but it's talking about your y value. So the only y value I won't ever get out is 3. So I'm going to get out everything from negative infinity to 3. So the whole bottom part of the graph I can get out, but I can't get out 3. But I can get everything above 3. So this 3 to infinity is talking about everything above this line. Your limits we can make more complicated, but we're not going to. It's not the point of this exercise. As your graph goes to the far left, so we're just thinking negative infinity, it is approaching your asymptote over here. And this asymptote, remember, is at 3, so it's going to be f of x equals 3. To the left, it's going to your horizontal asymptote. To the right, you'll notice it is also going to your horizontal asymptote, and so it's also f of x equals 3. Because again, over here, it's going to slowly approach this line. For relative extrema, while our graphs do curve, they don't fully turn around and go the other way, so there are no relative extrema. There's nothing that's higher than any other point or lower than any other point. These will either increase or decrease for the ones I'm going to give you, and this one, for example, as you go left to right, it's only decreasing, so I'm going to put none on increasing. And decreasing will be my entire domain. And then again, I'm just going to identify my x-intercepts from the graph. So my x-intercept is 3.667, 0, and my y-intercept is 0, 2.75. Okay, I'm going to do one more here, just talking through your charts, and then give you time to practice. This function here appears to have a horizontal asymptote that it's approaching. And so this is going to be an exponential function. So our equation, just again connecting it to last time, would look something like that. When we did exponential functions, your graph, it goes as far to the left as you want, as far to the right as you want. You can plug in whatever you want. So your domain is negative infinity to infinity. My range will be related to this horizontal asymptote. Again, I've drawn it in at y equals 1, and I'm only going to give you whole number values. So just find that closest whole number. But that means that my range goes from 1 to infinity, and it won't, negative 1. Negative 1 to infinity. It won't ever reach negative 1, so it does need to be a parentheses there. Let me make this a little prettier. Exponential functions did not have vertical asymptotes or holes. I'm going to go ahead and write none there. On the left-hand side of my graph, it's going to the horizontal asymptote. On the right side of my graph, it's going up forever. So it's going to be infinity. These don't turn around and change direction or have a real high or a real low, so I'm going to put none. This function here is only increasing, so negative infinity to infinity as it goes up to the right. None under decreasing. X-intercept is going to be this point right here, so the 1.369, 0. And then my y-intercept is this one, the 0, negative 0.778.